Designer uses two types of gravel for walkways. The larger gravel weighs an average of 40 pounds per cubic foot, and the smaller weighs an average of 48 pounds per cubic foot. In his truck, the designer has a 12 cubic foot load of gravel that weighs 520 pounds. If there is a mixture of both types of gravel in the truck, how many cubic feet of each type are in the truck? Now again, it doesn't look like there's enough information for us to be able to solve this, but we're talking about two things. We're talking about weight and we're talking about capacity, I guess I could say, but we're talking about cubic feet. Okay, so if I'm talking about the larger gravel, identify that maybe as being X. Okay, I'm going to call the amount of larger gravel we have as X, and I'm going to call the smaller amount of gravel Y. We could use different variables, but just because we're used to dealing with X's and Y's, a lot of time that's easier. So I know that the truck holds 12 cubic feet. Okay, so that means the amount of larger gravel I have plus the amount of smaller gravel I have is going to be equal to 12 cubic feet. Okay, because again, X represents how much larger gravel, Y represents how much smaller gravel. Now the second thing we can talk about is weight. I know that this larger gravel weighs 40 pounds per cubic foot. Remember, when you see that word per, that means we're going to multiply. Or it means, I shouldn't say it means we're going to multiply, it means it's our rate. So we know that however many cubic feet we have, we multiply it by the number of pounds. Same thing is true for our smaller gravel. 48 pounds per cubic foot. So I'm going to write 48y. And we know if we're talking about weight, this right here is weight, we have a total of 520. Okay, so again, even though it doesn't look like we have enough information to set up a problem, we're talking about two things here. We're talking about amount of gravels, 12 cubic feet total, larger plus the smaller. And then we're talking about total pounds here. So how much does the larger weigh? How much does the smaller weigh? Now what we can do is we can multiply it to solve for how much of each. What I mean by multiply is we're going to use linear combinations. So the easiest thing to do here, my guess, once we have our original system set up, is to pick a variable. I'm going to get rid of the X. Why not? And I'm going to multiply everything on the top here by the opposite of this coefficient. This is 40. This is, remember, is a 1. And I want it to become a negative 40. So I'm going to multiply each side by a negative 40. Remember, we can do whatever we want as long as we do it to both sides. Okay? So what that means, if I go negative 40, it's an x here, not a negative x, negative 40 times 1x, I get a negative 40x plus negative 40 times y, which is a negative 40y, equals, please don't forget that you also have to multiply, I should put this in parentheses so it doesn't look like minus, you have to multiply the other side of the equal sign by that as well. So 12 times a negative 40 is a negative 480. Okay. Again, now when we can go to combine that with our second equation, you'll see how we're able to solve for our missing variable. These cancel. That was the whole point of it. Negative 40 plus 48 is 8y's. And negative 480 plus 520, because remember linear combinations I'm using in this case to solve, would be 40. And if you divide both sides by 8, you get y equals 5. What does that mean? That means the amount of smaller gravel is 5 cubic feet. Okay, so how much of the smaller gravel? 5 cubic feet. Now, how about the larger gravel? Now that we know y equals 5, we can figure out what x equals. So I'm going to take this original equation here, this x plus y. You could use either one, this one's just easier, equals 12. And I'm going to substitute my y being 5. So x plus 5 equals 12. If I subtract 5 from each side, I get x is equal to 7. That means, remember, x represents larger gravel, we have 7 cubic feet of the larger gravel. Okay. So when you get your system set up, you can also use linear combinations to solve for it. That's one of our 3 methods. Make one of your coefficients the opposite by multiplying both sides of your equation, and then add your 2 equations together to figure out one of your variables. Plug that one variable back in to find your other variable. And that's how you use linear combinations to solve a linear system.